So now we're going to do some applications of chapter 9, couple examples. The first one, let X represent the average annual hours per person spent in traffic delays, and let Y represent the average annual gallons of fuel wasted per person in traffic delays. Do you guys see a connection between the hours you wait in your car and traffic and the fuel wasted? There could be a connection, definitely. The more hours you have to wait, the slower the traffic, just probably the more gas that you're gonna waste in there. So I think that there is a connection. We're gonna find out actually. So we put the hours that some people spend in traffic delay in L1, and you put the number of gallons of gas wasted in L2. The first question, guys, is to find the value of the correlation coefficient R and interpret its value. So how do you find R? Just you can go to stat, calc, number 4. Oh, it didn't show me R because I didn't set this calculator up. If it didn't show R, look what you do, guys. So that's a good point here. Just press second and number 0, and then scroll down to diagnostic on. As I said on Monday, if you reset your calculator, you have to do this every time you reset your calculator.
I have a question in the instructions under A. It says stat calc 8.
You can use 8 as well. It's A plus BX. It's the same thing, yeah. But 4 is closer, so we're just going to use 4. Yeah, that will be fine. So diagnostic, there you go. Enter. And done. Now, guys, if I go back to stat, calc, look, it's very straightforward, guys. Just use technology. And here's R, 0.794. Write it down. 0.794. Oh, I put 8. I could just change that to 4. That's more convenient. AX plus B. And if he asks you to interpret, you write there appears to be strong, positive correlation between hours spent in traffic delay and amount of gas wasted. That's the interpretation. Part B, at the 1% significant level, test the claim that rho is greater than 0. So guys, I already told you what the alternative hypothesis is. So your HO is going to be rho less than or equal to 0 and HA rho greater than 0. So we're going to run the test, linear regression t-test. Okay, let's run the test. Clear, stat, tests. I would scroll up because it's at the bottom and it's F. L1, L2. Okay, be careful, guys. You need to select the alternative hypothesis greater than and hit calculate. All right. So let's see what we have here. Let me write them down. So step 1, I got HO, HA, rho is greater than 0, rho is less than or equal to 0. Here, correlation is significant. And over there, correlation is not significant. Step 2, test the statistic T. which you guys can see on the screen, 3.204. Step 3, p-value, which you can see, guys, it's 0.0093. And I don't need the calculator anymore for now. At 1%, this is less than 1%, guys. So what's your conclusion? Your decision, step 4, reject, HO. And step 5, when you reject HO, guys, you say there is enough evidence at the 1% level of significance to conclude that correlation is significant. To conclude that correlation is significant between the hours spent in traffic delay and the amount of gas wasted on the road. And that's how you perform the hypothesis test, guys. And the reason you ask me why I chose positive, because he says test that rho is greater than 0. So correlation is significant. And when you reject HO, you conclude that correlation is significant. When you fail to reject HO, you say there is not enough evidence to conclude that correlation is significant. Part C, predict the number of annual gallons consumed when X is 30 hours. So we need the equation, guys, here. And actually the equation did show up right here. So let me just pick it up from there. Y equals A plus BX. And let me pick up the value of A and B. A is 2.81 plus, let me scroll down to get B, 1.44x. Okay, that's all I need. And now, guys, that should be easy to figure out how much gas is wasted when you wait in traffic for 30 hours. You just plug in X equals 30. So that will be Y hat equals 2.81 plus 30 times 1.44. And let's do it. So 30 times 1.44, guys, plus 2.81. I got 46 gallons.
Where did you get the 30 from?
Well, it's the question. Predict.
Thank you.
Find the value of Y when X is 30. So he gives you X. You cannot just make it up. So he gives you X and he wants Y. You just plug it in into the equation. If he gives you X is 28, you just plug in 28. X is 17, you plug 17, and so on and so forth. All right. Let me answer one more question. What's R squared and interpret its meaning? So we did, the calculator did show me the value of R squared. Let me just get it again. Stat, calc, number 4. And enter. You see, if your calculator is this one, it's not going to give you L1, L2. You just press enter and it's going to give you the values. So R squared, guys, is 0.63. Let's interpret the meaning of R squared. Change it to a percent. So here's what you write. 63% of the variation in the amount of gas, the variation of Y in the amount of gas wasted in traffic delay can be explained by the variation in the number of hours in traffic of the number of hours in traffic. So there are some other factors that affect, the consumption of gas in a car, guys. Can you tell me, you drive cars, can you tell me about other unexplained factor that this equation does not take into account using the regression line? So what other factors, guys, could have affected the consumption of gas other than just waiting in the car in traffic?
The size of your engine.
Very good. That's one. What else? The quality of the gas that you're buying, the age of the car, how old your car is, does it have issues, mechanical issues, etc. The size of the engine, that's a big factor. Is it a V6, V4, V8? So there are so many other factors, guys, that can contribute, just to the waste, just of gas, other than just waiting in the car. The habit of turning the engine off or on every time, just you have to wait in traffic. So there are so many other factors in there. All right. Next example. That's going to be the last one. And I would like you guys to take a minute to put your data in L1 and L2, and then we're going to answer those 5 questions. So the data below are the temperatures on randomly chosen days during the summer and the number of employee absences at a local company on those days. This exercise will check if there is a relationship between the temperature outside and the number of absences, whether when it gets hot, whether people are tempted, not to go to work or not. So we're going to see that. So enter your data in L1 and L2. My data, it's right there. L1 and L2. And the first question is to sketch it. So just go to Zoom and then number 9. So does it seem like, guys, that the higher the temperature, the more absences they are? Yeah, it seems like there is connection. You can see the line. This is the line of best fit, will be something like that. All right, so that's a sketch. Now, how does the homework online require you to do a sketch? Well, you do the sketch, you get this one, and then you go online, you're going to have 3 or 4 choices. You pick the choice that matches with this one. So once you see something where 2 points are close here, 2 points close, that could be your graph, and you just select it. Okay, so that's number 1. Number 2, test for a positive correlation between the temperature and the number of absences. Use alpha 0.05. Okay, we're going to do a linear regression t-test, guys, here. Let's do it. So I'm going to go to stat, tests, scroll up, and it's a linear regression t-test. L1, L2. All you need, guys, just to select up appropriate alternative hypothesis greater than 0, and that's going to give you everything you need. So calculate. So step 1, HO rho is less than or equal to 0, HA rho is greater than 0, and this is where correlation is significant. This is our claim, but we don't write a claim, we just write correlation is significant. And here correlation is not significant. So HO is bad for significance relationship, HA is good. Okay, test statistic, T is 13.031. P-value, you can see, guys, it's very small. So it's going to be 0. E minus 6 means I have to move the decimal place 6 digits to the left. So it will be 0.000001. Your computer is going to ask you to round to 4 decimal places. So that's less than alpha. Reject HO. In conclusion, there is enough evidence at the 0.05 level of significance to conclude that correlation is significant.
Can you move the paper up?
Of course. Okay, to conclude that correlation is significant between the temperature and the number of absences. So there is a connection, guys, strong connection. The hotter the weather, the more likely people will be absent, won't show up to work. That's what we concluded here. That's a part 2. That's part 2 of the question. Okay. So we answered 1 and 2. 3. Find the equation of the regression line. Round to 3 decimal places. But you already did it, guys. Here. We can go back. If you don't want to use this, you can use stat calc number 4. Y equals ax plus b. So 3 decimal places, he said. So that will be 0.449x minus 30.268. 449x minus 30, that's the b, 30.268. That's it. That's the equation of the regression line, guys.
Wasn't it negative 30.268?
Yes, and that's what I put.
Oh, I'm sorry. I thought that just meant subtraction. My apologies.
Yeah. You can put plus minus 30.268, but plus with a minus will become a minus. What would be the number of absences if the given temperature was 95? This is a typical question after the equation, guys. So he gives you x equals 95, and he wants the y value. So all you need to just plug in the x equals 95. So y hat will be 0.449 times 95 minus 30.268. I'm going to tell you about a common mistake that students make here. The students come up with, they swap A and B values and they come up with the wrong equation. So just be very careful, guys. Just watch the screen and copy it exactly as is. It says, it says AX plus B, attach the A value to X and leave the B stand alone by itself according to this equation. And then you will not make a mistake here. Negative 30.268. So let's see what the answer is. 0.449 times 95 minus 30.268. I got 12.38. So about 12 absences.
Can I ask one more question?
Sure.
Because it says y equals a plus bx, and you ended up switching it bx minus 30. Like, so if we wrote it out first, negative 30.268 plus b.
It will be the same equation. Yes.
I just want to make
yes.
sure. Okay.
Yeah, definitely. Look, if I say 7 plus 8 or I say 8 plus 7, it's the same thing, isn't it? So it doesn't matter. If I say 7 plus negative 3 or negative 3 plus 7, it's the same thing. Yeah, then fine. Yeah, that's fine. You can do it this way. 5. Find the coefficient of determination and interpret its meaning. So r squared, guys. And r squared, as you can see on the screen, it's 0.96. Change it to percent, 96%. So you're right. 96% of the variation and the number of absences can be explained by the variation in temperature. So 96% of the time, employees are absent because of the temperature outside, using the regression line. But that didn't explain the whole story. It only did 96% of the story. There's 4% connection missing. Can you guys give me some other factors that would attribute, just to employees being absent, other than the weather outside? Just to show you that there are some other factors that determine whether an employee is going to show up to work or not.
Vacation time?
Okay, vacation time, what else? They're sick. Didn't wake up on time, didn't set up the alarm, so there are some other factors, but they're saying here it's mainly the hot weather that will affect, whether the employee will come to work or not. Okay.
Oh.
You need just one more thing, guys, and I'm done with this chapter. Correlation and causation. Do you guys agree with me that there is a correlation between smoking tobacco and lung cancer? Correct? Does everyone agree with that there is a strong relationship between the two? It's a reason, just why some people, just people who smoke, just it is possible that they get lung cancer because of consumption of tobacco. But you need to know that correlation does not mean causation, meaning if there is a relationship between tobacco, smoking cigarettes and lung cancer, it doesn't mean that if someone smokes, just cigarettes, that he or she is going to get lung cancer. So correlation doesn't mean causation, and you just need to understand the difference between the two things. So if I say there is a relationship, just between quantity A and quantity B, I'm not saying that if quantity A exists, then that's going to cause quantity B to exist. No. If there is a relationship, that is possible that one would lead to another, but not necessarily. So that's a difference between correlation and causation. When there is a significant correlation between two variables, you should consider if there is a direct cause and effect relationship between the variables. It is possible that the relationship between the variables can be caused by a third variable or by combination of several other variables. So yes, smoking is a big factor, just that would lead, just to lung cancer, but that's not the only factor. People who get lung cancer could get it, just because they smoke, or it could be some other factors that are not determined, just by the relationship between smoking and lung cancer. So just keep that. And sometimes if there is a relationship, you notice a relationship between two quantities, it just be by coincidence, just it happens there, but that could be to a third, just it could be to a reason that you guys can see directly that will affect, just the variables. So sometimes we think, that two variables are related and one could cause the other, but to find out later there could be some other factors that we don't know about that are causing the relationship, but it appears to us that there is a relationship. So don't worry too much about correlation and causation, but I wanted you to just understand that correlation relationship doesn't mean that one causes the other. And that concludes the chapter, guys.